Let's say that we have the function f of x being defined by the second degree polynomial 5x squared plus 6x plus 5. The fundamental theorem of algebra tells us that because this is a second degree polynomial, we are going to have exactly two roots. Or another way of thinking about it, there's exactly two values for x that will make f of x equal 0. So I encourage you to pause this video and try to figure out what those two values of x are. So if we're looking for the x values that would make this expression equal to 0, that's essentially trying to solve this equation. At 5x squared plus 6x plus 5 is equal to 0. And there's no obvious way I can think of factoring this right over here, so I'll just resort to the quadratic formula. So the quadratic formula tells us that x, where x is a solution to this equation, is going to be equal to negative b. I'll try to color code it. Negative b. This is b right over here. Negative b, so negative 6, plus or minus the square root of b squared minus 4 times a times c times a times c, all of that over 2 times a. All of that over 2 times a. So what does this simplify to? This is going to be equal to, so let me go back to this is going to be equal to negative 6. I'll try to keep it color-coded still. Negative 6 plus or minus the square root. Now what is this going to be equal to? This is 36 minus 100. So negative 64, all of that over 2 times 5. All of that over 10. Now this is interesting. We are trying to take the square root of a negative number. Or another way of thinking about it, b squared minus 4ac is less than 0. b squared minus 4ac, which is oftentimes called the discriminant of this quadratic. This is less than 0. So if this is less than 0, this part of the quadratic formula, we're going to try to take the square root of a negative number. This is going to be a negative number. So we're going to result in an imaginary number. And so what that gives us are not two real roots, but two non-real complex roots. So this is going to be equal to negative 6 plus or minus 8i. 8i, the square root of negative 64 is 8i if we extend the principal square root function to imaginary numbers or complex numbers. All of that over 10. Or we could say x is equal to, let's see, if we find a greatest common divisor, if we try to reduce this, so we're going to have, let's see, they're all divisible by 2. So it's negative 3 over 5. That's the same thing as negative 6 over 10. Plus or minus 4 over 5, 4 over 5i. Or you could say that the two roots, which are non-real complex roots, so it's x is equal to negative 3/5 plus 4/5 I. That's one of the roots. And then the other root is x is equal to negative 3/5 minus 4/5 I. Notice, we satisfied the fundamental theorem of algebra. We have two roots. They're non-real, but that fundamental theorem of algebra says, hey, look, we're just going to have at least, if we're of nth degree polynomial, we're going to have n complex roots. They could be real or they could be non-real, and we see that right over there. We also see that they are conjugates. And the quadratic formula kind of sets up a situation where we are, especially if this ends up being less than 0, and so this, when you take the square root, you get an imaginary number, you see where those conjugates appear. Now let's verify graphically that this is indeed the case, that this does not have any real roots. So let's get a calculator out. So let me go into graph mode. So y is equal to, let me clear what I must have been doing out here before. So y1 is equal to 5 times x squared plus 6x plus 5. And then let me set a reasonable range here. So I don't know. Actually, I know very little about this function right over here. So I'm going to set a minimum range. I know -10, x max, I don't know, +10, x scale is 1. Let's see, y max. Let's see, this thing actually does get pretty big pretty fast. So let's say y max is, I don't know, the y scale, I don't know, I'll say 100. 100. The scale, I'll make it 10. Each of those notches are going to be 10. Y minimum. Well, we want to see the x-axis to make sure it doesn't cross it. So let's go at negative, I don't know, -20. And now let's graph this. I'm hoping that I've actually captured it, and I have. So there you have it. You see that this thing does not intersect the x-axis. And in fact, we could zoom in on it. Let's see, it's a little bit hard to. It's a little, actually, let me just change the range a little bit. So let me just change the range. So let's make our x min, let's make it 5. Let's make our x max, whoops, not 50. Let's make that 5. And let's make -5 and +5. And then let's see, let's make our y max, equal to 20. And then our y scale, I don't know, we can make it 2. Okay, I think this will get us much closer in to, there we see. It does not intersect the x-axis. This does not have any real roots, but it has two non-real complex roots.